Hi everyone, welcome to this comprehensive overview of databases on AWS. In today's fast-paced business world, data is king and managing it efficiently can unlock immense potential for insights and growth. This content dives into cloud databases, highlighting their cost advantages over traditional systems. We'll cover Amazon Relational Database Service, Amazon DynamoDB, Amazon Redshift, and Amazon Aurora. In this content, we'll explore four key AWS services: Amazon RDS for relational databases, DynamoDB for NoSQL, Redshift for data warehousing, and Aurora for high performance relational needs. Let's get started with the basics of databases in the cloud. The business landscape is evolving rapidly, and companies that leverage data effectively gain a competitive edge. Databases are the backbone of this, allowing accurate recording, updating, and tracking of information. Cloud databases, in particular, offer significant cost savings compared to on premise setups. Before diving into specific services, it's crucial to understand unmanaged versus managed services on AWS. Unmanaged services like running a web server on Amazon EC2 instance give you discrete resources that you specify, but you must manage load changes, errors, and availability yourself. For example, by adding auto scaling manually. This offers granular control but requires more effort. On the other hand, managed services such as Amazon S3 for storage need minimal setup, like creating a bucket and setting permissions, and automatically handle scaling, fault tolerance, and high availability internally. For databases, this means shifting from managing hardware and backups yourself to letting AWS do the heavy lifting. This reduces operational overhead, allowing you to focus on your application. Next, we'll see how this applies to relational databases and the challenges they pose when unmanaged. Running your own relational database on premises or in an unmanaged setup comes with significant challenges. You're responsible for everything: maintaining servers, managing energy and hardware, installing and patching software, handling database backups, ensuring high availability to prevent downtime, planning for scalability as data grows, securing data against threats, and even patching the operating system. These tasks demand resources, expertise across multiple areas, and can pull you away from innovating your own applications. For instance, a sudden spike in traffic could overwhelm your setup if not scaled properly, leading to outages. This is where managed services like Amazon RDS shine. They automate these burdens, providing cost efficient, resizable capacity while letting you optimize your app's performance, availability, security, and compatibility. Let's explore Amazon RDS in detail. Amazon Relational Database Service, or RDS, is a fully managed service that sets up and operates relational databases in the cloud, addressing those unmanaged challenges head on. Instead of handling hardware, networking, HVAC, or even OS patching yourself, AWS takes care of it. If you're migrating from on-premises, RDS offloads tasks like scaling, high availability, backups, and patching so you can focus on application optimization. For example, moving a database from EC2 instance to RDS means AWS manages the OS and software updates automatically. RDS supports six popular engines: MySQL, IBM DB2, Microsoft SQL Server, PostgreSQL, MariaDB, and Oracle. You access it via the same tools as standalone databases, making migration seamless. The basic building block is DB instance, an isolated environment with customizable class, storage, and performance based on your needs. Amazon RDS offers powerful features for reliability and performance. DB instances are isolated environments containing multiple databases with resources tailored via instance classes and disk types for optimal cost and speed. Running in a VPC gives you control over networking, selecting IP addresses, IP ranges, creating subnets, and setting ACLs, often placing the DB in a private subnet for security. For high availability, multi availability zone deployments create a standby copy in another availability zone, synchronously replicating transactions to minimize data loss during failures or maintenance. If the primary fails, RDS automatically fails over using the DNS endpoint, so no code change is needed. Read replicas supported for MySQL, MariaDB, and Aurora asynchronously. Copy updates for offloading reads, scaling heavy workloads, or reducing latency across regions. These can be promoted manually if needed. Together, they ensure your database is robust and scalable. Amazon RDS excels in scenarios needing relational data handling. For web and mobile apps, it provides high throughput and massive storage scalability, with high availability fitting variable usage without licensing hassles. E-commerce businesses benefit from its flexibility, security, and low cost for online sales, ensuring smooth transactions during peaks. In mobile and online gaming, where latency matters, RDS manages infrastructure so developers focus on gameplay, handling high request volumes effortlessly. Use RDS for complex transactions, medium high query write rates up to 30,000 IOPS, single node setups, and high durability. Avoid it for massive rates, sharding, simple get put requests, or heavy RDBMS customization. Opt for no SQL or EC2 hosted database then. Estimating RDS costs involves several factors. Billing based on clock hours charges accrue while the instance runs. DB characteristics like engine, size, and memory class impact pricing, as do the number of instances for peak loads. Choose on demand for flexibility, pay hourly, no commitments, or reserved instances for savings, low upfront for 1 to 3 years. Storage is provisioned with free backups up to 100% of your allocation. Extras are billed per gigabyte per month. Consider I/O requests, deployment type, multi-availability zone increases costs for redundancy, and data transfer, inbound free or outbound is tiered. To optimize, use reserved instances for predictable workloads, potentially slashing hourly rates. This makes RDS economical for most use cases. To wrap up, it's a managed service simplifying relational database setup, operation, and scaling, freeing you for business focus. Features include scalability, automated redundancy, backups, and support for engines like MySQL. Choose SSD options for high performance OLTP or cost effective general use with no downtime scaling. It leverages AWS's reliable infrastructure and VPC for enhanced security. Now transitioning to non relational databases, Amazon DynamoDB. Shifting gears, let's compare relational and non relational databases. Relational ones, like those in RDS, handle structured data organized in tables, records, and columns with defined relationships using SQL for interactions. They are great for complex queries but may struggle with horizontal scaling or semi structured data, often requiring joins. Non-relational databases break from this model, excelling in handling variable data, scaling out easily, and working with unstructured formats. They are ideal for modern apps needing flexibility. This leads us to Amazon DynamoDB, a prime NoSQL example. Amazon DynamoDB is a managed NoSQL database delivering single-digit millisecond latency consistently, regardless of scale. AWS handles the infrastructure, storing data redundantly across facilities for fault tolerance. create tables, and add items flexibly, even with varying attributes without schema migrations. As data grows, DynamoDB auto-partitions storage and scales throughput manually or automatically. No limits on items. Some tables hold billions. Data resides on SSDs for low latency queries. Key features include global tables for multi-region replication, at-rest encryption, and time to live for auto-expiring items. It's perfect for mobile, web, gaming, ad tech, and IoT apps needing high performance. DynamoDB's core includes tables as data collection items, as uniquely identified attribute groups, and attributes as invisible elements. Use partition keys for simple identification or composite keys, partition plus sort, for sorting. As data expands, it's partitioned by keys for efficient access. Retrieve via queries using keys for fast location or scans for non-key matches. Those scans are less efficient as they check all items. Design keys thoughtfully, like using GUIDs or author title combos to optimize queries. This structure supports quick scans and queries in large tables. DynamoDB runs on SSDs supporting document and key value models for versatile apps like gaming or IoT. Access via console, CLI, or APIs. Scale throughput for consistent performance under heavy loads. Global tables simplify multi-region replication for availability. It's suited for high request scenarios where latency impacts user experience. Now let's move on to Amazon Redshift for data warehousing. Analytics drive business decisions, but traditional data warehouses are complex and costly to build. Amazon Redshift changes that. It's a fast managed service for analyzing petabytes of structured data using standard SQL and your BI tools. It employs query optimization, columnar storage on high performance disks, and massively parallel processing for sub-second results. Start small for 25 cents per hour, scaling to $1,000 per terabyte per year. Redshift Spectrum queries terabytes in S3 directly. Redshift's architecture features a leader node coordinating with clients and compute nodes, parsing queries, compiling code, and aggregating results. This parallelizes operations for speed. Automate admin tasks to focus on data. Scale effortlessly as needs change. Security includes built in encryption. It's compatible with familiar SQL tools and connectors, increasing integration. Redshift suits migrating enterprise data warehouses for agility, handling massive big data loads affordably, and enabling SaaS providers to offer analytics. It reduces costs via managed features. The key takeaways of this is it easily scales nodes with downtime, use columnar storage and parallel processing for performance, auto monitor and backup with built-in encryption. Now, let's look at Amazon Aurora. Amazon Aurora is a relational database compatible with MySQL and PostgreSQL, designed for the cloud. It offers high-end performance and availability at open source prices, reducing costs while boosting reliability. As a managed service, it handles provisioning, patching, backups, recovery, and failure detection automatically. Aurora stands out for availability. It stores multiple data copies across availability zones with S3 backups using up to 15 read replicas. Crash recovery is instant, under 60 seconds without replaying logs, performing it on reads instead. The buffer cache survives restarts, avoiding throttles. It's drop-in compatible, pay-as-you-go, and integrates with migration tools for easy shifts. Aurora reduces costs with cloud-built reliability, distributed storage, fault-tolerant design, multi-availability zone replication, and S3 backups. Security via VPC, KMS encryption, SSL. It's compatible with open source engines managed by RDS for automation and ideal over standard RDS for superior availability. In summary, this content covered Amazon RDS for managed relational databases, DynamoDB for NoSQL speed, Redshift for analytics, and Aurora for high performance relational needs. You learn their functionalities like RDS, multi availability zones, or DynamoDB global tables, and how to perform RDS tasks. Cloud databases meet modern app demands, terabytes of data, millisecond latency, millions of requests. Choose relational for structured queries, NoSQL for flexibility, and match to use cases. Thanks for watching and subscribe for more AWS insights.